everyone, welcome back. This is Asha Singh, and we are back with the second day to the AIML roadmap series. And yeah, this is day 2 with the Python fundamentals. And I hope you guys have already started and you have also gone through some documentation here as well. Yeah, coming back to our worksheet, I think we have already discussed very basic things. We have discussed the variables and the data types. I hope you have gone through it and you have the clarity on it. And yeah, so let's start with our data types. So first one is number. So I think we have already discussed the two of them, which is an integer and a float. And there is one more which is we'll discuss. Let's start. Yeah, sorry. Okay, so in Python it support different numeric values. So the three main number types are integer, which we define as an int. Yeah, second is float point numbers, which we define as float. The data type is float. Next is complex number, and the data type is complex. And how we define it: a equals to 10, it is an integer. It can be a negative as well, and it can be a 0 as well. Okay, integers are whole numbers, either can be positive, negative, and 0. Yeah. Second is float. Float are numbers with basically a decimal point. For example, 3.14 minus 2.5 and 10.0. Okay. Next is complex number. So complex number are the numbers that are in two part. First is the real part and second is the imaginary part. I think in mathematics we used to learn about complex number, how to do operation on it, and I think the same remains here as well. Like one thing you have noticed till now, I think we have discussed the variable and few operations. So one thing I have discussed, so this is similar to the mathematics that we have been studying from our academia, right? So the same thing, how we work like with a pen and a pencil, now we are doing it on a computer screen, and how we are doing it is we call as coding. Yeah, so yeah, okay. So complex number, again, how we define it as, for example, 2 plus 3j. 2 is the real part and 3j, here 3 is the imaginary part. Okay, yeah. Again, how we check the number types. Yeah, so let's start with our yeah, okay. So let's start with int. How we defined it, we already discussed it above. Let's say we have a number 1, which is 3. It can be negative as well. So integers are whole numbers, right? It can be negative, positive, and 0. Yeah, so if I print it, it should print me num 1, num 2, and num 3. It should print me 3 minus 4 and 0, right? Makes sense. Now also check their types. So we know how to do that. Simply do type num1, type num2, type num3. Yeah, that's how we can check their data type. So all three are integer, like we discussed that the integers can be positive number, negative number, and a 0, basically a whole number, right? Yeah, next is float. Let's define it as float 1 equals to 1.15, float 2 equals to minus 2.5, and a float 3, let's say 0.0. So now if again let's say I print the variable name and their type, float 2 and float 3. So it should show me the variable first, 1.15, 2.2, minus 2.5 and 0.0 and their respective type, which should be float, right? Now let's define a complex number. Okay, how we define it? So for example, let's try doing this, and we print the data type. Let's see, yeah, it works, right? But now I want to see their real part and their imaginary part. Okay, so this is, here the real part is 2 and imaginary part is 3, right? 3. And here, sorry, right? Yeah, here the real part is 0 and imaginary part is -1, right? Because the reason being, we can write it as 0 plus -1 j. Okay, and now let's just quickly print the the number and their the number and their real and imaginary part. Okay, complex one dot real and imaginary, and similar for number 2. Yeah, like if you are saying it's very it's it's easy to read, right? The readability factor of Python is very good. So how we used to define it in our academia, in our school time, so 2 is the real number and 3 is the imaginary part. Similarly, that's how we are calculating it as well. Like the complex one, this is the variable, and dot real, it will give me the real part, and dot imaginary, it will give me the imaginary part. So now let's run it. See, it's working, right? Okay, so it should be -0 instead of, I think -0 plus 0 is same, but yeah. Okay, so that's how it is. Next is type conversion, like we discussed above, how we can convert. I think we already discussed how we can do it. So for example, let's define 3 variable nx, let's say 1, y equals to 3.14, and let's say z equals to 1j. Okay, so I have defined a integer, a float, and a complex number. Okay, now let's try converting first integer to float. Okay, integer to float. So how we can do it? Let's give it a equals to float. Yeah, now if I print it, so it should work. Yeah, so x was 1, so let's do this also so that it's clear how it's changed. Okay, so the x was earlier, it was int, and after the conversion it is of float type, right? Now let's do float to int. I know it's a repetitive, but let's do it, because practice makes a man perfect, like the saying goes. And if you if you keep doing it, you will get the hang of it. Okay, so now y we have defined as 3.14, and now we are converting it to an int, so it should be 3, right? Let's print it. So yeah, so earlier it was float, but now it is int. Yeah, let's try converting int to a complex. Okay, okay, let's see how it goes. Yeah, see, so earlier it was 1 int, now it become 1 plus 0 j complex. Now let's try something. Let me just do one. Okay, now let's try something. Let's change this z to, let's say, 1 plus 1j. Okay, now let's try converting complex to an int. Complex to an int. Let's see if it works or not. Okay, so we have d equals to int z. And now let's quickly print z d d z. Let's see if it works or not. You see, it did not work. Yeah, makes sense. This conversion failed. Yeah, okay, I think this is clear. So what we have got from it, that we cannot convert, let's say, yeah, let's try for example, let's try again for, so this is something that happens. So let's again do one thing. So here it failed. Let's try to convert complex to float. Let's see if that works or not. Okay, let's make it e. Let's try this thing also, e, and it should be float. Okay, and if we run it, yeah, so it's giving me a type error. Okay, so basically the conversion fails again. Yeah, so what we have concluded, what we have got to know is that we cannot convert a complex number into another number type, but we can do the vice versa. So let's try. I think we missed one, so we try to do integer to complex. Let's try again, like float to complex. Okay, float to complex, and it should be y. Yeah, y, f, and f. So I'm really sorry for my naming convention, variable name conventions, but I think it works, right? So let's check. Yeah, where is it? Yeah, so it works. No, sorry, this one. We try to convert float to complex. Yeah, it works fine. And why it is working? Because it is taking the float part as a real part, and it's just adding 0 to the imaginary part, right? But for the vice versa, it does not. It was not able to convert it. It is like fixed in the back end somewhere. Maybe we can, like, you can, if you come, let's say if you come across something like that if there's a complex number, something like this, then if somebody is trying to convert this to a integer or a float, then it should take the real part. That's one can derive or create another functionality out of it. But currently Python does not work, okay, like this. Yeah. Okay, next is we'll talk about one more thing. Here is the random number. So yeah, should we discuss it now? Let's discuss it. Okay, so if you see here what we are doing, so for example here, so when we are defining this complex, so it is a function, okay. Somewhere it is a function in the whole library of, if you see the documentation as well, and if you go to the documentation, if you see the module index, there you will see that where this complex is defined. And if you want, so currently it is failing like this with the type error, but if you go into the code and if you change it, like let's say if you tweaked it a little bit to take the real part as the float or the int, you can make that change into the library in itself, and then it will work fine. Okay, so basically these are defined somewhere, right, where you can make the changes. And yeah, so the similar way, there is a built-in library which is called random. So this is, don't worry about it, like we'll discuss it later how, what does this import mean. Import is basically the word itself, that we are taking this library, we are importing this library into our workspace. Okay, so this is a package, this is an inbuilt package. Once you install Python in your local library or somewhere, if the Python is installed, then this is an inbuilt library. Okay, you don't need to externally install it. Okay, so how it works, so for example import random, and this can be used to generate a list of random numbers. For example, you want to create a random number, random number 1 between let's say from 1 to 10. So what you can do is you can, yeah, so this is the library and this is rand range, and you can mention that 1 to 9. So if when I've defined 1 to 10, so it will take from 1 to 9. Okay, so if I run it, it will find me a value between 1 to 9. But if I want to get a value between, let's say, 10 to 19, so I have to mention here 19 plus 1 equals to 20. Okay, so now if I run it, so it will give me a value between 10 to 20. Make sense? I think it does, right? Okay, typecasting I think we have already discussed. So when we do something like d equals to int z, what we are doing is we are typecasting it. We are making the data type, the variable type of d as an int. Okay, so if we write a equals to string hello, or if we write b equals to string 2, and if I print a and b and respectively their type of a and type of b, they will both be string. Okay, makes sense? So this is called as typecasting. Okay, I hope the number type, number data type is clear. Okay, let's move to the next one. Next is Python booleans. Okay, like we discussed above, so these define the truth values. So it can only be 2, whether it can be true or whether it can be false, and it should be like the it should be the true should start with capital letter T and false should start with capital letter F. Okay, so Python has two built-in Boolean values, true and false, and should start with capital T and capital F. Booleans are often crafted by comparing values. For example, 5 is greater than 3. True, right? It's like in English language how we use it. 10 equals to 5. No, right? So it should be false. 7 is less than equals to 7. True, right? And Python with the capital P equals to Python with the all small keys. It's not, right? So it should be false. Okay. The Boolean, so there is a Boolean function as well, bool function. So it converts a value to true either to false. For example, if you remember, we have tried doing something change to Boolean, and somewhere here, okay, we did try to do something above. Yeah, I'm not able to find it right now. So yeah, so once if we use bool function, if we try to typecast, let's say, an integer to bool, then it will return it to true because something is there. But if we try to bool a 0, it will be a false. Again, if we try, let's say, a string John, it will be a true. If we pass an empty string, it will be a false. This is a list data type, we haven't discussed it, but if it is an empty list with a square brackets, it should be false, and if there is some values inside a list, it should be true. Yeah, okay, let's quickly do this. Okay, for example, if I defined a boolean as boolean 1 equals to true, boolean 2 equals to false, and if I printed and print the type, it should be true or false. And but if I change the false with small, all small, then it should fail with an error, right? So it can strictly like it is case sensitive. Okay, yeah, okay. Okay, next is, for example, if we do this print 1 is greater than 2, is it, if I just ask it in a normal language, okay, is 1 greater than 2? No, right? No, right? So it should be false. So if I test it, it will be false. If I say hello equals to hello, so it will be, right? So it works the same way. Basically, we are checking two values with each other. But if, let's say, if I say hello hello greater than 4, let's see what it says. So it will throw an error because we cannot compare a string value and an integer value, right? Hope it's making sense. Yeah, next, evaluate variables and values and variables. So like we discussed about typecasting. So if I typecast a string hello to a boolean, it should be true, right? But if I typecast an empty string, then it should be false, like we discussed above. Yeah, if I'm typecasting an integer 50 to bool, it should be true, right? But if I am typecasting integer 0 to bool, it should be false. Let's try it. Yeah, if I'm bool casting 0 to integer 0 to boolean, it should be false. If I'm typecasting 15 to boolean, false. True, sorry, empty, false, and hello, true, right? It works. Okay, like we discussed that some values are false, like empty, 0, or an empty list, or an, yeah, yeah. Okay, one more point, which is like functions can return boolean. So for example, don't worry about like what are functions and how we define them, but just try to understand the concept. For example, let's define a function. Let's say function 1, and what it is doing, it is just returning 2. Yeah. And if when I run this function, I call this function, it should print me true, right? But let's change it now, let's change it to return false. So it will return false. So we can return boolean variables to our functions as well. Okay, next is instance function return a boolean. Okay, so for example, you have a variable defined somewhere throughout your program. Okay, and you don't know like the data type of it, you don't know what is it, right? So for example, let's do this first. For example, I have defined a variable x which has a value of 200, which is an int, right? So how I can do it, so is instance is a method name, the name itself defined like is instance. If you hover it a little bit, so it also mentions that return whether an object is an instance of a class or of a subclass thereof. Okay, so x is an instance of int, true or false. If it is an instance of true int, it will give true, otherwise it will go in false. Yeah, but let's say if I say here it's a bool, so it should return false, right? Because it's an int. Yeah, that's how we can do it. Okay, I hope it is clear, and I hope you are doing good and you are able to understand it, whatever we have discussed so far. I know these are the very basic things, but I think these are important as well.